And this is a bit of a story of a 4-year preceding process of actually working on a piece of infrastructure that in the beginning looks very easy. It's an easy business case, but it's a really hard technical problem where we've had to, use open collaboration spaces in order to actually deliver some value. But before we get into that, I'll just present Energinet. We're the Danish state-owned TSO. We own the electricity grid and the gas grid, and we operate it. So we're in the middle of the value chain, of the energy value chain in Denmark. And what we can do with that is, of course, apply this strategy. And the strategy is bound by a lot of political will. Currently, with the green transition, there's a lot of push to actually put a lot of joules through the energy system. So we have to roll out infrastructure at a rapid pace and secure the green energy supply, and then just make sure that the markets are functioning at an equal level for everybody, so everybody can participate. So it's actually quite a lot of things. Just sourcing the stuff and actually getting the grid to work, and then actually looking at it and thinking, can we even get enough supplies to do that, or do we have to have a different strategy? And this is where digitalization and innovation comes into play. Because it's not small things that we have to deliver towards 2050. It's just, this exploding gradient of energy that we have to get through. So we have to look at the problems differently, obviously. And that's just the challenge we have, and that's throughout the company. And that's, so we have secure critical infrastructure. Without power, we wouldn't be doing these presentations today. It's just the basis of civilization. So we definitely see this, and we are based on renewables in Denmark. We have oil and gas, but in the long run, we need a renewable source. So that's how it looks. The thing is, with renewables, you get a lot of fluctuations. You get the volatility, and you have to address that. So it's not the same control mechanisms that we've had in the past that we can apply in the future. We need to think of this differently, which means we have to create the right incentives. Am I right? On top of that, we get all these different energy sources into the grid. We have had a system where we had power plants and it got delivered to the end user. We built a whole grid around that idea. So there are things that are physically impossible, even though it sounds benign and easy, but it's just not in place for us to actually deliver that. So it's becoming more complex. And then we have this whole idea of actually coupling the different sectors, the different energy carriers. So we need to figure out, how do we actually account for that? It has to be possible, but how? So in short, we have gone from a classic delivery system where a producer puts energy into the grid, there's a distribution trade, and it hits the consumer. And now we look at a very much more decentralized system with a lot of different energy carriers. So, it's quite a headache. It's just complex. So this is why we brought in innovation. So we have research, which is fundamental research. That can be quite a long time before it actually reaches the market and deliver the value and the impact that we are expecting, especially politically. And then we have industry where there's a lot of regulation, so we have to comply. So in this field, there's just one thing, it's actually thinking about the problems differently and try different solutions. So that's how we try to appropriate these emerging technologies, to actually make them have a fit into our business case. So the requirements for appropriation, when do we appropriate a technology? We need to figure out a way to actually collaborate in the open. Because you can't do this with a tender. You actually have to go out and say, all right, we have a common problem, we have a common mission, would you like to join us in that? Then we need a proof of technology for the business case to actually work. We have to make something work to convince and also make it reasonable that this will actually deliver the value and impact in the future. And then, yeah, I touched briefly on the vision. You need operational solutions, so it has to be some sort of concrete idea that can go into production at a certain point in time. And what we see a lot is a lot of prototypes, and when people that doesn't have a technical edge, they see it, they expect it as already in production. And working software and prototypes are two different beasts entirely. So, with that in mind, we'll go to a practical example. We call these granular certificates. We'll dive into what that means, because that's why I brought a video for you. And I hope the sound works. I'll give it a go. If not, I'll explain it to you.
At Energinet, we know where your electricity comes from. Do you? For 100 years, we've used electricity without needing to wonder where it comes from. But today, with so much electricity from renewable sources, we have a choice. That choice is becoming more and more important as lorries, ships, and planes move to green fuel made with green electricity. And we can choose green electricity. Sort of. When we use electricity while the sun isn't shining or the wind isn't blowing, it comes from fossil fuels. So when you get a green electricity guarantee today, it's not a snapshot of a particular moment, but a picture of a whole year. The guarantee means that the same amount of green energy will be produced as you'll use over the year. Just not necessarily while you're using it. That's why it's impossible to know if the energy you're using right now really comes from renewable sources, making green electricity a bit murky. But now Energinet has a solution. Energinet has built an IT platform that crunches all the data, meaning the source of your consumption can be detected by the hour. Consumers can now power up on entirely green electricity without any murky patches. Businesses can prove they're sustainable. And we can ensure the fuels of the future can document that they're truly green. Energinet accelerates green transition every hour. So, will you join us?
And that's more or less the pitch about it. It's not a platform per se. It's more of an approach to actually solving this issue, because as we will see, it's just not having an idea where your energy comes from, because we'll never be able to trace the electron. It's not a traceable unit. It's an assumed unit. However, there's a long way from the yearly guarantees of origin, where you can actually be certified green at night from solar power. That's just not how the world works, is it? So, but that's where we are. We have these yearly guarantees. It's an authority-based trust model. Trust us, here's the guarantee. Where we have to move into the hourly, that creates a lot more certification that has to happen. And so it's no longer just, an accounting practice. It's actually a piece of technology we need to look into. And then in the future, we have to do some verification of time if we want to make sure that we have 50 hertz in our energy sockets. It's a completely different beast, but let's start one thing at the time, and that will be on the hourly or spot market level, which is 15 minutes in Denmark now. So before we had the guarantees of origin, they have been working great for the 20% penetration of renewables in Europe for the last 20 years. It's based on yield settlement data, and the main difference on the granular certificates is they are time volume based, and they align with the spot market. So you can certify your energy at the same intervals as you settle the markets. The issue is that just on issuance, on the 15-minute basis, you get 35,000, roughly, certificates a year. And then you have to be able to transfer them, you have to be able to claim them, etc. So it just creates a lot of data transactions. But our business developers love it. That's why you saw that video before. It's just a great idea because it can deliver all sorts of things, premium solutions for electricity, community, energy management systems and corporations. You can do power to X, you can do all sorts of things, but it requires a technical foundation. So that's where we started to deliver on those downstream values. And that was the hot topic at the time and still is. We can do data-driven value creation from spot billing data. And the thing is, in Denmark, we have it in our shop at Energinet at the data hub. But it created a problem space for us where, as we went around the shop and started talking to all the stakeholders, we had to make sure of a lot of things. First of all, create these stateful certificates. One of a sudden, it's just not a piece of data. It actually has state, so I had to ensure that. So you couldn't make double claims and these kind of things. A digital copy is unrecognizable from the original. So how do you do that? We have to make sure we don't leak sensitive private information. It's pretty sensitive stuff. I know when you're at home, if we start publishing your hourly watt hours spending or consumption. We have to make it publicly verifiable, et cetera, make it scalable and make sure each transaction is unique and compliant and bootstrap a market. And please go do that now. Sincerely, management. So what can we do about that? Well, my first idea was, okay, we have to call in the cavalry. We have to have a different perspective on this. And we needed to develop some sort of proof that it is possible. And that is where the open collaboration and especially open source is valuable, because then we can just, give it a license, and we picked the first one. That was Apache. Great. Now we have some sort of framework of actually sharing the work we're doing. And then it was actually finding who are the cavalry. But what we did first was actually write and publish our ideas. There's been a lot of work going into it already at the time. So why not write it down and put it out there in the open and see who responds? And that has shown to be very effective in the Brussels business of actually pushing legislation so you make sure that that doesn't become a problem down the line. So these were the participants in this specific Project Origin setup. We had the Alexander Institute, which is a GTS institute that is trying to make adoption of fundamental research applicable in industry. Then we have Mural Informatics. It's a consultancy. They know a lot about consulting house, and they are really good at building things at scale. And they know the energy infrastructure from 20 odd years. And then we had Concordium, which are a blockchain company that has hired some of the best cryptographers in Denmark. So we actually had an idea, all right, we should not roll our own cryptography. That is just a big no-go. So we better ask somebody that knows how we could do this stuff. And the great thing was they actually had a pretty good idea how this would be possible. But the first thing we did was simply just get a Blackboard in there, no fancy presentations, and then start working on the problem. And it actually came quite immediate that, all right, it's actually doable. And what we did was we got our programmers to try out the theory. And then we could test the theory, and when we hit problems, we just had that working group and we would go back there. And it was a pretty open space. Nobody was pushing for their solution. It was more head scratching, like how do we figure this out? And then people came together, especially in lunch breaks for some reason. And that delivered that value we needed. Otherwise, we wouldn't have gotten here in the first place. So it started on Blackboards. True Professor Hand there. A lot of ideas, but we fleshed out an API as well. And it ended up looking something like this. And this is the stateful certificate that becomes issued. Then it can be transferred. And transferred is actually a bit an understatement. That means you can have a market. So you can start buying up wind. You can start buying up solar for the end consumer to claim it. Because I don't believe anybody will sit there and actually certify themselves on the hourly data. That'd be crazy. I have to make sure. That's not how we think about it. This has to be an automated process, but it has to be reliable. So that's the reliability of verifiable proofs for the energy supply chain. And the true big innovations of this project was the Merkle proofs, and that guaranteed uniqueness and immutability and was actually auditable, because you can go down in the tree and actually certify that in that proof that has been published, that your transaction is included. That makes for all these state transitions in the object itself, that you can actually verify it has happened without leaking any information about what happened, but that it is true. It makes for us to be able to prove millions of events without publishing all of it, and that we can actually make sure that the registries are tamper evident, so nobody is changing the records afterwards that have published the proof. Then you can actually go back and say, all right, please go through the records again, make the proof, and then we can compare. The Peterson commitments were more on the individual certificate, and that was to obfuscate the values of the certificate itself. So in a specific hour, you could get issued 200 watt hours of production, and then making sure that, first of all, that you cannot go back and figure out what is it 200 hours, and still make sure that there's only that volume available, and make individual claims on it. And tomorrow there's a talk that goes through this by Mr. Torben Pedersen, who invented this back in the 90s. So now we had the unique and verifiable proofs. And it kind of, broke this triangle of pain, as we called it. We have a non-storable asset. We only have the metering data. We have a huge amount of data volumes that we have to address, and we have to make sure it's trustworthy. So now we have that piece of the puzzle. So it's about getting to build stuff. And this is the state diagram of the granular certificates. They get put into a registry. The registry itself is quite naive, but the wallets are the ones who can prove ownership. And if you have ownership of part of granular certificates, then you can do the transfer, you can do a claim, and the rest is actually up to the operator to remove it if it's faulty. That was the tricky part. Some measurements are faulty, so how do we actually remove it? We have addressed that, and they have to expire at a certain point. So we don't get, you start accounting for it back in time, like 10 years or something like this. So that is Project Origin. It can handle registries, and you can have wallets where end consumers can actually exchange parts or parcels of these granular certificates and claim them on against their production. A granular certificate on production side is the same as the consumption side. One is plus and the other is minus, right? So you have to have some consumption in order to claim some production. So, in brief, we store all the certificate state transitions in a registry. It's an event store. We obfuscate the details, and then we create and publish the Merkle proofs as a way of being reliable. That means that all of a sudden we have documentation as a commodity, and that can spawn whole ecosystems. You can have the classical PPAs that can be settled on spot hour levels. It can add specificity at a level we haven't seen before, and then we can actually use it as a standard. That was the cool thing in energy track and trace, where we've been working with other TSOs. Elia Group, 50 Hertz, Elring. At Elia, they had a registry running, and we actually tested, and we were able to send ownership back and forth. It works, it's great, and it can handle a lot of transactions. Another output was that we published this in Springer Journal of Energy Informatics back in 23 and went to conferences. You can check out Project Origin, it's already open source. So one of a sudden we have these unique and verifiable digital proofs, and we've been running pilots with a lot of commercial actors, 600 I think, in Denmark, and they've been able to claim against their production, consumption and production on the hourly for 6 months. In energy track and trace, where we established that, the international parties, we made it available for open source so other TSOs could actually do that. What we found is that there was a lot of setup, has to be simpler, and that is where it becomes a lot more interesting for something like Linux Foundation of Energy. But what we found is that we could collaborate as TSOs around the more of the structural part of the project. But we needed public-private partnerships in order to actually build the code that worked, find a solution that would actually deliver. And what it garnered was a lot of attention from international bodies, AIB, NSOE, Energy Tag, and the Commission, et cetera, et cetera, et cetera. So doing this work actually opens up a whole bag of worms and a lot of work that you can address by doing these things. Start doing stuff instead of talking about it. So these are the key takeaways. Make it mission-driven. Know that you don't know everything. An informal network approach made open collaboration easy. We didn't have to sign contracts. We had that in the Apache license. Make scoped engagement so other companies don't waste a lot of time and effort into nothing. And go open source. But is it a market-ready solution? Not at all. What we found that it's a commodity. It's great, you can enrich data, you can engage in tokenization, which is a hot topic right now in the European Commission. But can you deliver the value? It requires a full value chain. Everything has to function, and we are like 30% of the way. And then if you don't have that functioning value chain, how do you figure out what the price will be? What will people pay for it? Right now, it's really cheap to be green. So what if that changes? What we found is that the governance part was really hard. It was not hard to make the technical stuff. And then actually the continuous buy-in from the members, you know. Tides change, seasons change, and political observations and attention changes. So that is the hard part, and this is why Linux Foundation of Energy makes sense, because this is what's being brought in. But some sort of governance tool. Because it's not easy to have an open collaboration and then add governance. How do you agree on that? So right now, we came up with a solution for granular certificates. What we didn't fix was the federated network part. And we know with the federated network part, we can start doing decentralized balancing. So we are open for ideas and pull requests at all times. What we need to do, the federation, or what we have addressed, is in order to decentralize, we need to have cryptographic consistency so they can check each other without having to do audits. It has to be a built-in part of a protocol. And then we need to establish governance like the DAOs that we know from the blockchain space. The thing is that what we can actually get of impact and value is that we can start addressing these huge imbalances we have from renewables. It can be quite wild on a sunny day like this. And then we can actually start seeing some different business models where you can get a fridge with power if it, you know, starts accumulating energy at times where it's in surplus, and you can certify it. Well, mine is actually green. It's actually coming from solar. Or I have a battery that charges only when it's sunny, and the 50% loss is from solar. So this is the nice part. Right now, the status is that it's being onboarded by the Technical Advisory Committee right now as becoming a LF Energy project. We propose that in the future we target, you know, the home energy management and community energy management systems from the bottom up. We are TSO, we've done it from the top down. It hasn't worked sufficiently, but the techniques have been validated. And then we'd love to expand the working group. If you want to know more about Project Origin and how these proofs work, join us tomorrow where Torben Pedersen from Concordium will come and actually deep dive into the Merkle proofs, and especially the Peterson commitments, which are quite interesting. It's simply double locks, if you've seen in Terminator 2 and other movies. It's digital versions of that. And that's tomorrow at the Helium room from 3:30 to 5 o'clock. If you want to know more about Project Origin, please reach out to my colleagues, Jesper Villersen, who's sitting there, and Peter Ingerslev, who have made a great generative AI black and white picture of him, and then myself, Thomas Wisbech. And that's it. Thank you for your time. Do you have any questions?
Thank you, and thanks for bringing it at least for the third year in a row on the stage so we can see you progressing. It's been like a lot of progress.
Yeah, it's actually us that build it now. It's not just business developers.
Just
Third time lucky.
Two questions there. First one, very simple. When you say granular certificates, it is in the energy tag compliance sense as well, isn't it?
The energy track and trace implementation in Denmark was the second certified energy tag compliance solution, and it was based on the technical merits of it. So we have that. We have been. It's been quite a tedious process, to be honest, because it can be hard working with people that have no technical edge at all to actually understand what we've been doing on the cryptographic side. But I think the documentation speaks for itself, and that's why it got energy tag compliant, and we got the certificate from them 2 months ago.
Nice. Second question, a bit more sort of high level to make sure I've probably understood what you were saying. Like this example here is a case of technology preceding market uptake and adoption.
Yes.
And so basically what you're telling us here in the presentation is we've got the tech to support those things, but we miss an ecosystem and a market that's going to take it up.
I think you address an important problem here, because what we see from especially a lot of prototypes and emerging technologies is that they have a lot of promise. However, there's very, very far to actually having working software and delivering value. And that gap is widening by the day. And I don't know how to address that, to be honest. I think Linux Foundation of Energy is a great forum to have this discussion. The thing is that yes, we can solve it individually, but at scale, things just get a lot harder. And we need to figure out how to actually get there, not faster, but in the right way. Because a lot of software projects, there's a lot of decision being made, and you might be able to make a wrong turn at the very last hour, and then it doesn't deliver what you wanted. And working with blockchains and these kind of things, you cannot change it afterwards. If you publish somebody's private information, it's there forever. So these kind of things, you have to be very, you just have to have attention to detail and make sure it works before you start saying, oh, this is working infrastructure. Especially in something as important as critical infrastructure as energy. I think you have to be even more cautious and tenacious about using the right practices doing that.
And then to be slightly provocative, let's imagine there's a company that says, we can enable a marketplace tomorrow for those certificates. How long will it take you to support the first transaction in a way that you're confident?
This is an interesting one, because it's already happened. The thing is, from business value, where businesses today sell stuff that doesn't exist. And what we have experienced in this working group is that they just want an API, then they're happy. They don't care about the trust issues. I do. And the consumers do. But the business does not. They just want an API. Why doesn't it work yet? So there's just a huge gap right now, as I see it. most businesses today, they put together the stuff that will make it barely work so they can go deliver on the value proposition. It's cool. The thing is, what about all the stuff that's happened before? And we've seen that at Energinet. We have a data hub where users can go in and see their data, on the hourly. And it was first when, the spot price started peaking in 2021 that it got the value and attention it deserved. And that was 10 years after it was put into production. So these are the timelines we're looking into. Any other questions?
Who will be issuing those certificates?
Huh?
Who will be issuing those certificates?
We were looking at it as you do with the guarantees of origin that are issued by issuing bodies. That's the association of issuing bodies. And Energinet is already an issuing body in the guarantees of origin scheme. So it has to be some sort of trusted party. The thing is, if you go down to the home energy management systems, it has to be data-driven instead of authority-driven. So we have to make sure that we have some sort of trust all the way down there on the edge. And we haven't addressed that problem yet, We are a centralized TSO in that regard. So this is our perspective on things, or the Energinet perspective on things. And this is where I come in as a technologist and say, oh, we could do this different, but I don't have the answer to it. Right now we trust the metering operators to put in a meter that can send you billing data that you can trust, right? Errors can happen, and then, they get addressed. So you cannot have endless immutability. You have to be able to, pull back some certificates that were faulty, etc. So you have to have some sort of way of securing your data cleanliness. And we're going to see that with AI now, because garbage in equals garbage out. So there will be coming emerging technologies that would look into a data source and see, is this trustworthy or not? And I think that could be applied into a home energy management system, etc. But it's a great question. Can we trust the issuer? Any other questions? All right. Thank you very much for your time, and have a great day.